Hey, it's Mr. K, Chemistry 30, Unit C review, question number 7. All right, now this is a long one with a lot of distractors. I didn't like the way the question was really written because it's trying to ask 3 things, but by canceling out 2 every time, it's really only asking 2, so here we go. All right, state, deal with it. All right, they've given us this picture, and they've asked the monomer that makes up this polymer contains a blank, and the structure of this polymer closely resembles the structure of the polymer found in blank. This polymerization reaction is classified as blank. Okay, lots of pieces going on. Here they come. So first of all, monomer means the smaller pieces that make up a polymer. Mono one, poly multiple. Now looking at this thing, here is a picture of that repeating group that they have drawn above. Now I've just replaced the line diagram with some simple carbons. And now looking at this thing, we just have to think about what's going on. Now, I'm going to tell you this part is that we are getting I'm going to write it with red. We're going to have an H here, and we're going to have an OH here. Now, what I see looking at this thing and why I know this is because when I look at the next step, the repeating group. Now, again, here's what they've drawn. I just cut off what I had in blue. If you think about it repeating after and after, what you're going to see here is you should see an ester group or an ester linkage. And when I see ester linkage, what I'm thinking about is an acid and an ester, an acid and alcohol, or in this case, a carboxylic group and a hydroxyl group. And then I can see that what's going to happen here is the H and O are going to pop off. The H is going to pop off. I'm going to get water somewhere, HOH. And then I'm going to get this repeating ester group. So that gives me a lot of pieces. First of all, by recognizing this is an ester repetition or an ester linkage, I know that a carboxyl and a hydroxyl group must have been present first. So I was able to cancel out my double bond. Secondly, it asked me what type of polymer this is. Well, again, it's an ester, so I chose polyester. And then lastly is an addition or a condensation. Now, for me, when I'm thinking addition, I'm thinking about the double bond type of polymerization. For condensation, I'm thinking about that water condensing off and being produced, and that's how I remember the two. So looking at this thing, I'm looking for that polyester group, realizing it must have been a carboxyl group and a hydroxyl group, forming a polyester, and I know that from that water being formed, it's a condensation. Okay. This is in contrast to, let's just talk about the distraction they were giving, the propene one. So if I have propene, what's going to happen is H. Okay, so propene. What would have originally happened here is this would have started off as a double bond and made it 1, 2, 3 proponene. But that double bond, those electrons that make this thing up, they go here and here. And then what happens is they form a chain of more of this group. And what we get is we started with propene, and now when we put it into its polymer form, we get polypropene. We just don't even look at the fact that the double bond's gone. We think about the fact that it was there. We recognize the monomer was propene, so the polymer becomes polypropene. This is an example of an addition. When you're taking a multiple bond and breaking it apart and just adding monomers on top of each other, whereas a condensation, you need acid and alcohol group so that you can form a polyester. Okay, thanks a lot for tuning in.